Okay, this is MAC 1105 and we are doing section 4.2. In this section, we're learning how to go back and forth between equations that are in logarithmic form and equations that are in exponential form. And eventually you'll be graphing both of these, learning properties, but the very first thing that we're going to learn how to do is to go back and forth between these two forms. So they're basically giving you the formula for doing that right here. They're showing you that when it's in log form, the base that you see right here is the base when it's in exponential form. It's just when we write an expression in exponential form, its base raised to an exponent is equal to x. So what you're going to do with this is if they hand it to you in log form, you're going to raise up the b because it doesn't hang down like this off of the log word. It'll just be raised up, but it'll still stand for the base. The item that's by itself will come over and become its exponent, and then the x, which was with all these other terms, will go and take the place of this. So these two things switch sides. So the x goes over and the x goes over and is by itself, and then the y comes over here and becomes the exponent. Okay, so the b stays on the same side, y comes over and becomes the exponent, x switches to the other side and is by itself. We're going to be going back and forth between these two definitions. So when you're going from this definition to that, I would write the word log, immediately drop that b into position, and then again switch the sides that these two things are on. And you'll see me doing that as I go through these next few examples. So when you're going through the next few examples, I would just maybe cover up what you see there just so you're not looking at the answer all finished. And I would just practice moving everything into position. So we're already in log form in this case, and we want to get it out of log form. So you're going to take this base, push it up like this, go grab the item that's by itself, and it's going to become the exponent, and then the x, which was not by itself, will now be the item that's by itself. So basically these two things just switched responsibilities. The x is now by itself, the 3 is over here where all the action is and has become the exponent to the base. And as you can see, that's the answer right here. And then if you go to do the next couple, again, just so we're not looking at the answer, you're going to push that base up. Go grab the number that is all by itself because now it's going to be the exponent to the base. And then the 25 will be all by itself. And the reason that you're doing this is because when the numbers are in the form of an exponential equation, you're not able to solve them. But as soon as you throw them into exponential form, then you have a chance of either solving them in your head, or pressing them in the calculator if the numbers are large. Like for instance in this one, unless you already know what 7 to the third is, you might want to just use your calculator. But you can at least solve it once you get it into this form. This one, you can also solve just by observation. Here you'd need your calculator. Here you would be, what value squared is 25? And the answer is 5. Okay, likewise, let's try this one. Again, you're going to take the base when it's in log form, raise it up, still acting as the base. The item that's by itself becomes the exponent. And the 26 is now by itself. Is the term that's isolated on one side all by itself. And then again, you have all these answers right here. Okay, on the next page, we're going to go back the other way. We're going to, instead of start with log form, we'll start with this form and go back this way. Okay, one thing to remember when you're going to go into log form, because you're being presented with this, is whatever is the base here is the base here as well when it's in log form. And then the remaining two items will switch sides. Okay, so like for instance, again, let's just cover those up for a minute. Okay, if we want to go to log form, you should begin by writing the word log and the equal sign. Right away, take the base and put it where the base belongs. In log form, it's hanging right off of the word log. Let me move this over so we have a little bit more room. And then the remaining two items, we've already used the two, are the 5 and the x. The 5 is now going to be by itself where the x is, and the x is going to come over to where the log is. And there you go. You have that in log form. And you have the answer right there. Okay, next. Again, going into log form. So here's your log. There's your equal sign. You should put the equal sign in so you can establish the left and the right and help yourself focus. This is the base. Put that in position first. Once you've used that, there's only two more items left. If the 3 was not by itself, it now will be. And the 27 will take its place. It'll come over here where all the operations are that are going on. And there you go. There's that answer right there. Log of 27. When you read this out loud, it's read. Log of 27 base b is equal to 3. And this last one, when you're writing these, you can either use log or ln. You're going to see that typically in a lot of the problems that concern e as a base. E is the number 2.7, and then there are other numbers that come after that, but that's just an approximation. It's a number like pi. It's irrational. So we use the symbol e for that. So we're going to be using it with natural log, but you can also use regular log. These are called log, depending on what base it is. They talk about that as the common log, and ln is the natural log. But we'll go ahead and use logs, just since that's what we're using. And take the base, drop it right here into base position. You only have 2 spots left at that point. The 33 that was by itself will no longer be by itself, but over here where all the operations are going on, and the y will go over and take its place. So those two things switch sides, just like they did here, just like they did in the first example. Okay, and there's the answer right there. And all of these can be flip-flopped. It doesn't matter whether the single item's on the left or whether it's over here on the right. Okay, now using these to write equation, we're going to take the equation and write it in exponential forms. So then you're going to go into this problem, and when you're coming out of log form, now these are like the 3 problems we did on the first page, you raise this up. Go grab the item that's by itself. That'll become the exponent. Put your equal sign, because these are equations that you're rewriting. Here we're going from a log equation to an exponential equation. So I mentioned the 5, the 4, and you could even check that in your calculator. You could go 5 raised to the 4th. You'll see that it's 625. And you can check them if all 3 items are numbers, all 3 terms. Okay, here. Again, same thing that I followed here. When going from log form to exponential form, you will simply push this up, and it was acting as a base here. It'll still be acting as a base. Go grab the term that's by itself, because now it will not be by itself. It'll be the exponent of that base. Put your equal sign, and the only number that you haven't mentioned yet. Now, while you can't check the validity of this in your equation by just pressing in numbers like you could here, you can solve it. Going from log form to exponential form makes that possible to solve these equations. This just says what squared is 81? 9. So by observation, you can square this, not by moving things from side to side like you would a more simplistic algebra equation. Okay, here's another one of these. Start by pushing the base up, but still letting it act as the base. You can put your equal sign. The value that's by itself, whether it's on the right or on the left, now becomes the exponent. And then at that point, you've already used those 2 things. This is the only thing left. You could also solve this. 3 to what power is 81? You could just go into your calculator if you're not familiar enough with your powers. I'm sure everyone in here knows 3 squared is 9, and probably all of you know 3 to the 3rd is 27, so the next power up is what this would be equal to. Now, they didn't ask you to solve this, but I'm just saying in sections that come after this, you will have to go to that extent. You'll rewrite them, and you'll solve them. Okay, write the equation in its equivalent logarithm form. So all of these we started with a log and then we went into exponential form. Okay, that was all of those. Now we're going back the other way. We're in exponential and they're asking you to go to log form. So in that case, and we're just practicing all over again what we did on the first and the second page. On the first page, we had all these problems that were in exponential form, or they were in log form, and then we took them to exponential form. And then when we got to this page, they were in exponential form, and we took them to log form. So you're just practicing all over again those same concepts. Okay, so when you're going into log form, start by writing the word log and the equal sign. So you have a left and a right. Okay, this base here will still be the base. Number by itself will no longer be by itself. And the 2 that's the exponent will be over here by itself. So you're going back to its original log form. And then you can just leave it like that. And let's go on to the third page. Okay, here, I'm going to continue. We're going to go into log form. So this is log, and you can put your equal sign there. You have your base here, your exponent here. What acts as the base here also acts as the base here. So you're done using that number. Only 2 things left to mention is the -4 and the fraction, and they are going to switch sides. Item that's by itself will no longer be by itself. It'll be over here where all the log operations are. And then the -4, only thing left that you haven't mentioned. Okay, and that is it in log form. Then here, you're going to want to rewrite this in power form because everything you've been given thus far where you've been asked to put it in log form has been in exponential form, and that this is not in exponential form. So if you recall from MAT 1033, the way you write a radical with an index in exponential form is you ask yourself how many of these are occurring underneath the radical, 1 of them. So you could call 125 to the first power. So this is 125 to the first power. That's what's underneath the radical. So that's part of the power. And the bottom is the 3. Everything that's in radical form can be written in power form or exponential form, but the exponent will always be a fraction. Okay, this is part of that fraction. It's the numerator. And this is the other part of the fraction. Okay, so radicals turn into exponential expressions, and the exponent's a fraction. Okay, so this is what you're looking at. 125 to a power of 1/3 is equal to 5. Now you can go into your logarithmic rewriting that we've been doing in a lot of these problems. Okay, put the log and the equal sign. Whatever is the base here will be the base here. Okay, you're done with the 125. What's by itself will no longer be by itself. And then the 1/3 swings over here. And this is equivalent to this. 1 in log form, 1 in exponential form. Okay, this one's already in exponential form, so you can jump right into log form. Put your log and your equal sign. This base remains as the base. And then these 2 switch sides, just like in these 2 problems. So the x that was by itself now comes over here where all the action is, and the 3 swings over and takes its place. These are called properties involving 1. You're going to see that this relates to the inverse property on the next page. Basically what this property says here is if the argument and the base match, the item out front or the value out front is the argument, and this is the base. When those match, what this entire side is equal to is whatever this power is. So it works for powers other than just 1, although they're introducing it as a property of 1. It's going to be called the inverse property on the next page. If this matches this, they take each other out with the word log, and the power that's here is what it's equal to. Then there's also the log of 1. Doesn't matter what the base is, as long as the base is greater than 0, because remember those properties that were on the first page. Let me just remind you that the base and the argument both have to be values that are greater than 0. So I'm not going to say it can be whatever it wants to be. Okay. All right, so log of 1 for anything with a base greater than 0 is going to be 0, and you can even put that in your calculator. So those properties are going to come up, and you're always going to want to use them when you can, because some of these problems will say to simplify them as far as possible. So those properties help you do that. So here they are again, basically restating that first property that I just had on the previous page. When the argument matches the base, they take each other out because they're inverses. Log goes with them, and this value will be what you see over here, what it's equal to. The inverse property can also be stated in a different way, as you see right here. So when the inverse property is stated as an exponential function where the exponent is a log, just look to see if the bases are the same, then this inverse property can be used. Sorry about that. And the value that's here is what it'll be equal to. All right, applying these properties, we'll do numbers 8, 9, and 10. So if you want to use this property here, where the argument is equal to the base, then you have to try and rewrite it like that. So this can very easily be rewritten so that this and this matches. You want to write this in power form. That's this number right here. Write that in power form such that this base is going to match that. So this can be written as log of, when I rewrite this in power form, I want to use a base of 6, just like I see there. So this can be rewritten as 6 squared. And in doing so, you have this matching this. So the inverse property applies just like it says here, takes the word log with it, and the exponent is what it's equal to. Here you can also apply that property. You might need your calculator for this one. But again, if I see a little hanging base of 2, I'm going to try and rewrite this number in power form using 2's. So this will be log of 2, and then you can fiddle around in your calculator to figure out 2 to what power is 128, but it's 2 to the 7th. And you can check that in your calculator. 2 to the 7th is 128, but in any event, I have the argument matching the base. Therefore, this inverse property applies, taking the log with it, and that's equal to 7. Problem number 10. Again, you're going to want to, if you want to try and make this work, if you want to try and apply the inverse property, then you have to write the argument as an exponential expression, something to a power, and the base of this exponential expression has to match the base of the log if you want to try and use this property, which you want to use anytime you possibly can. So I am going to rewrite this in exponential form, or power form if you want to call it that. Mean the same thing. Okay, so since I see a little 8 hanging there, I want to rewrite this as 8 to some power. And again, if you recall from MAC1105, you can write anything that has an exponent in the denominator in power form. Only because it's happening in the denominator, we rewrite it with negative exponents. So the power on the 8 was a 1, but since that exponential expression was happening in the denominator, it is rewritten with a negative exponent. In doing that, you have the inverse property that applies. The argument matches the base, takes the word log with it. This is equal to negative 1. And that is it for section 4.2.